Okay, so these were the ones we either solved by factoring or we used that even root property or the square roots. So for 11, we're factoring. What are the factors of -8 that sum to -2? Good. -4, +2, and then we split and solve, and we get x equals 4 and x equals -2. For 17, we obviously can't factor this, right? So we add the 43 to the other side. X squared equals 43. Square root both sides, putting a plus and minus in front of that 43. Can I simplify 43? Square root of 43. Nope, so it stays just like that. For 21, I would square root both sides, putting the plus and minus in front of the 24. I get x plus 9 equals plus and minus square root 24. Can I simplify square root 24? Yeah, right? It would be 2 and 12, 2 and 6, 2 and 3, and then 2 2's go to the outside. So x plus 9 would equal plus and minus 2 square root 2 times 3, which is 6. Then you'd have to subtract the 9. So you can either write this as -9 plus and minus 2 root 6, or separate it out, -9 minus 2 root 6, and -9 plus 2 root 6. No. No, if it's standard, if it's in standard form, that's how they'll put it. Like if you see it in multiple choice, that's how they like to put it without the root at the front. But it's not wrong in the other order. As long as the sign, as long as your plus and minus is on that 2 root 6. Yeah. Okay, so this was number 1. So you're solving by factoring, right? So I'm going to take this 4x squared plus 2x equals 0. Factor out a 2x, and I get 2x plus 1. And then split and solve them. So this I'd divide by 2. I'd get x equals 0. Subtract, so they equal to 0. Subtract the 1, 2x would equal -1, divide by 2. And x is -1/2. So -1/2 and 0 should have been the answers there.
Could you go back to 17?
Remember that I said we are going to learn multiple ways of solving quadratics. So quadratics is x squared, right? We're going to learn a bunch of different ways to solving them. Yesterday we did factoring and the square roots. Those will be on your quiz along with the equations with your fractions, okay? And then this is the third method, which is called completing the square. Just like for future reference, this is something that my pre-calc honors advanced kids are still struggling with from last year. Okay, so this is not something that goes away. The ones that like have a gap in it from last year because they were like, this is not important, were lying to themselves. It doesn't go away. You're going to see it over and over again, okay? But this process is called completing the square. What we're going to do is take something that's not a perfect square trinomial and force it to become it so we can factor it and then use the square root property to solve it. So the steps are as follows. We're going to obviously go through this with numbers, but just so you have it here in case you get stuck. The first thing you're going to do is you're going to keep the ax squared and the bx terms on the left side of your equation. And you're going to bump the term that doesn't have a variable, so the constant, to the other side. If there is something attached to the x squared other than 1, we're going to factor it out at that point. So let's say I had, I'm just going to make numbers up, but let's say I had 2x squared plus 3x minus 1 equals 0, okay? First thing I would do is bump this over here. So I'd get 2x squared plus 3x equals 1. Then if there's a number attached to the x squared, I'm going to factor it out. So it's going to come out in front of the parentheses, which means it comes off of both of these terms. And my middle term is now 3 over 2. We're going to find the c term, which is what's going to go here, by doing this. Take that second term, divide it by 2, and then square it. We're going to add it to this spot here, and we're going to add it to the other side of the equal sign to balance out our equation. Whatever I do to one side, I got to do to the other as well. And the goal for that step is to make what's in these parentheses a perfect square. If you've done that, then we'll factor it, which is the square root the first term, square root the last term, take the sign from the middle, put it in parentheses, and square it. And then you're going to solve using the even root property or the square roots, just like we did yesterday. So we're basically forcing it into the format in which we can use square roots to solve it. We're going to go step by step, slow and steady. So what was step 1? Move the 14 to the other side. So x squared minus 4x, bump the 14 to the other side. What's step 2? If there was something other than 1 here, I got to take it out of the parentheses. Lucky for us, because we're baby stepping our way into that yucky business. There's nothing there, so I don't have to take anything out. Which means I go to the next step. Take the b, which is this number here. I'm going to ignore the sign because I end up squaring it, so it will always be positive. I'm just going to take the 4. Divide it by 2 and then square it. So 4 divided by 2 is what? 2, and 2 squared is 4. That's what I'm going to add to the left side and the right side of my equation. So I get x squared minus 4x plus 4 equals 18. Yep.
How did you get 4/2 again?
I take the middle term, whatever's attached to that x, divide it by 2, and then square it. Always. Yep. So now my goal here was to make the left side become a perfect square trinomial, so I can factor it. I square root the first term. I square root the last term. I take the sign from the middle, put it in parentheses, and square it. And now I have this in standard form. And I can solve it with what we did yesterday. So how do I solve it from here? Square root both sides, putting that plus and minus in front of the 18. I'd get x minus 2 equals plus and minus square root 18. Can I simplify square root 18?
Yes.
Yep, that's 2 and 9, which is 3 and 3, right? So this becomes x minus 2 equals plus and minus 3 square root 2. And then add the 2. So I get x equals, the 2 can be at the front or the end, it doesn't matter as long as the plus and the minus is on the 3 root 2. Yes? The plus and minus has to stay on the 3 root 2. Yeah. Mm-hmm.
On the homework, it was asking us if the estimate for value or something that's right.
No. Good so far. We're going to do it again. Step 1. Move the 1 to the other side. Step 2. Good. There's nothing on the front to take out. If there was, I would. But if not, I go straight to the 6. 6 divided by 2 squared. 3 squared, 9. Add the 9 here. Add the 9 here. So I get x squared plus 6x plus 9 equals 10. I made it a perfect square trinomial. So now I factor. Square root the x squared. Square root the 9. Take the sign from the middle. Put it in the parentheses and square it. And to solve, good, square root both sides, put the plus and minus in front of it. And then subtract the 3. Yep.
Will the third term that you have to add in, will it always be positive?
Mm-hmm. Because we're always going to square it. And it always completes a perfect square trinomial, so it has to be positive. Right, because we square root it. You can't square it to negative. You do this one. Sure, like if you have plus and minus square root 6 minus 1, like that you mean? Yep, that's fine. So if I had done this process with something that's factorable that wasn't a perfect square, at the end I would get a square root that you could actually square root, and then you'd be able to go further. Like I would get square root 25, that's 5, and then I could actually go further with my answers. So everything that we worked out by factoring can also be done this way. In my opinion, I would choose factoring over this one, but if you get stuck, it could, every quadratic, sorry, I should say. So not like the factor by grouping kind where it was x to the third, or the perfect cubes are perfect, yeah, perfect cubes you can't. But all the other quadratics you can also do this way.
For web assignment, which one should we put first?
I don't think it matters, except pay attention to the smaller, larger. So the smaller would be the -1 minus square root 6, and then the larger -1 plus square root 6. Yeah, I think the answers format the same way. All right, so now they get a little bit harsher, okay? Because you start to see things that the middle term is not even. So what's going to happen when I divide by 2? I'm going to have fraction, okay? So it's still the same first step. I'm going to move the 12 to the other side. X squared plus 7x equals -12. Now I take my 7, I divide it by 2, I square it. I'm going to keep it as 7 over 2. I don't want you putting that as 3.5 and then dealing with decimals. You keep it the fraction, but it's going to stay as 7 over 2. Then I'm going to square it, which means square the 7, square the 4. Square the 2. So 49 over 4. That's what I'm going to add in here and add in over here. So on the left, it's still a perfect square trinomial. I'm going to square root the x. When I square root this 49 over 4, it's the same thing as going back to what's inside the parentheses here. So if you want to remember, just go back to that spot instead of square rooting and square rooting, you can. But hopefully it doesn't take you long to square root 49 and square root 4. That's where the 7/2 comes from. Sign comes from the middle, put it in the parentheses and square it. And now I got to find a like denominator over here. -12 plus 49 over 4. I have to multiply by 4 and 4. So -48 over 4 plus 49 over 4 is positive 1/4. Sorry, that should equal 1/4. Equals 1/4. You with me so far? Now I got to solve it. I got to square root both sides, putting a plus and minus in front of the 1/4. I get x plus 7/2 equals, what's the square root of 1? What's the square root of 4? 2. Subtract the 7/2. And I get x equals -7/2 plus and minus 1/2. Can I keep going? Yes. Yep. There are two answers here. One in which -7/2 is being subtracted from 1/2. And then -7/2 plus 1/2. So this is -8/2, which is -4. And this is -6/2, which is -3. So unless there's a square root that can't be simplified in your last statement, you got to keep going. Go back to your original questions. Are there factors of 12 that sum to 7? Much easier to factor that, right? Does that make sense? Yeah, if you have the choice. If it's complete the square, it's going to say solve by completing the square, and then you'll have to do it this way. But if it's just quadratic and you could choose, factoring's going to be way easier there.
So on a test, are there going to be questions where we have to do it a certain
Yep.
way?
So you have to do it by this way, you can't do it factoring, or?
It will say solve by completing the square. That's one thing, but also they're not all factorable. Like the last ones would not have been factorable. If there ends up being a square root in your answer, it means it wasn't factorable.
Also, can you just skip the first step and do 49 over 4? You just go directly to 7 over 2.
But you have to know to add the 49 over 4 to the other side. Yeah. All right. You do 5. What's different now? There's something on the front, right? Just like with factoring, it sucks more. It's going to suck more with complete the squared too, okay? So step 1 is still the same. Move the 1 to the other side. 9x squared minus 12x equals 1. Now step 2 is take the 9 out, which means take the 9 off or divide it both terms. So the 9's going to go on the front outside parentheses. That means I'm dividing this by 9 and the negative 12 by 9. Sometimes it goes in evenly, not so bad, okay? This is one of those cases where it's really yucky because 9 does not go evenly into 12, right? So the first term becomes x squared, but then what is 12 over 9 in the most simplified form? Negative 4 over 3. Now what? First, divide it by 2, and then we square it. So when you're dividing a fraction by 2, it's the same thing as what? Multiplying by a half. 2 goes into 4 twice, and so I'm taking 2/3 and I'm squaring it. And I get 4/9. You with me so far? So now, before I can add 4/9 to the other side of this equal sign, I have to multiply by the 9 I took out. Yep.
Why don't we divide the 1 by 9?
Say that again.
Why don't we divide the 1 by 9?
This is how we take care of that. So we're only taking it out of the front of these two terms because that's what's on this side. But then before I add the 4/9 over there, I'm going to multiply it by the 9, which would have been the same thing as if I divided by the 9 and then added the 4/9. We just do it differently. Yeah.
Instead of taking out the 9, instead of taking out a 3.
But then you still have a term in front of the x squared, and it has to be nothing there. Yeah. Okay, so whatever I am going to add to the other side, if I took something out on that's on the front of the parentheses, I have to multiply by that first. So I'm multiplying by the 9, and I end up canceling these out, and I just add 4. Now the 9 is still on the front. The square root of x squared is x. The square root of 4/9 is 2/3. The sign from the middle is minus. Put it in the parentheses and square it. And then 1 plus 4 is 5. Do what? Pretend like that never happened. All right, now I got to solve it, right? What would you do first? Divide both sides by 9. X minus 2/3 squared equals 5/9. Then, first square root, right? Square root both sides, putting the plus and minus here. I get plus and minus. Square root 5 is going to stay as square root 5, but the square root 9 is 3. Add the 2/3. And I get x equals either 2 plus and minus root 5 over 3 or plus and minus root 5 plus 2 over 3. So fun, right? Like the most one can have doing the math. Yep. Bella.
You know in fractions, you always put the plus and minus in the numerator?
Yeah, yeah. You could put it like so that if it was on the no, you would put it with the root 5 either way. Yeah, yeah,
Wait, you skip those?
yeah.
The bottom, I think they're the same because it's used on the other side, so it doesn't matter.
Say that again.
Like, the answer for left, it's like, they're both, the twos are both positive, so it's the same thing, no?
Yeah, I was just saying you could write it either way. Yeah, you could write it in either order. Kiara.
If we did this like the way we learned yesterday, would we get the same answer?
You wouldn't be able to do this like you did yesterday.
This is like the only way.
Well, you're going to learn quadratic formula. You're going to learn a fourth way that you could do. But you can't factor this, right? There's like no factors of -9 that sum to -12, so I can't factor it. And for the even root, the square roots, you can only have one x. You can't have an x squared and an x. Yep. All right, we're going to do one more. We could do it. I believe in you, folks. Do you want to try it, or you want me to do it with you? Let's try it, see how far you can get. All right, so we group together the first two terms. You take out the 3. You take the 2/3, divide it by 2 or multiply by 1/2, and then square it. You get 1/3 squared, which is 1/9. Add the 1/9 inside the parentheses over here. And then I would normally add over here, but I got to multiply by the 3 first, which means I'm going to add 1/3. So in a minute, I'll show you a different way to do this, and then you get to choose between those two. Okay, but that's one way to do it. Excuse me. On the left-hand side, you're going to take the 3 and then square root the x squared, it's x. Square root the 1/9, it's 1/3. Add 5 and 1/3 and you get 16/3. Then to solve, so that's this step here. Then to solve, divide both sides by 3. You'd get x plus 1/3 squared equals 16/9. Square root both sides, you get x plus 1 equals plus and minus 4/3. And then subtract the 1/3, and you'd get x equals -1/3 plus and minus 4/3. There's no root there. They both have the same denominator, which means we got to keep going. Split it and solve it, and you end up with a +1 and a -5/3. How'd we do? Okay. Nobody fell over. Nobody cried. Nobody puked. This is a good sign. Okay. All right, so let me just show you because you have this option. When you get to this step, let's say we're here, and I've got 3x squared plus 2/3 x equals 5. Before we find that missing term, you have the option of just dividing everything by 3 to get rid of it, okay? Or even from the step before it. Here, actually, we could do it from here. From here, you can divide every term by 3. So I'd end up with x squared plus 2/3 x equals 5/3. The steps on the left are still going to be exactly the same as they were. I'm still going to do 2/3 divided by 2 or times a half squared. I'd still get 1/3 squared, and that's still 1/9. I add it here, But this time I can just add it straight to that 5/3. I don't have to multiply it times the 3 on the front first. So this is up to you. You can choose either of those methods, okay? But on the left, it ends up just being x plus 1/3 squared. On the right, you still have to find a like denominator. So that would still be 15/9 plus 1/9, which is 16/9. And then go through the process that we just did. Square root both sides, like all of that process, okay? How you choose to do that is completely up to you. Yep. Yeah. So instead of taking the 3 on the outside of the parentheses, we just divide everything by 3. So my original equation was 3x squared plus 2x minus 5 equals 0, right? So I moved the 5 over, still first step the same. And then I divided everything by 3. Instead of putting it on the front of the parentheses, I divide everything by it. So I'd get x squared plus 2/3 x. The other side of my equal sign is the fraction, which is yuckier there, but I don't have anything on the front of my parentheses. Does that make sense? And then I can go through the process like I did before. Middle term divided by 2, squared it the whole bit. So yeah.
You can do them for like, you can do this for like any other ones, like the one that we just did.
Yeah, yeah. And the reason I tell you this, one, when you use this in pre-calc honors advanced, you use it in a different way, so you can't do this method. But when you're solving it and when it's equal to 0, you can. And the reason I say this is on something like, I'm going to go back to 8 and 9, but on something like 10, it's way easier to just divide everything by a -1. So if I bump, I'm going to keep the negative x squared here plus 3x, and I bump the -5 to the other side, I'd still have to get rid of that negative. So in the first method, I'd have to take out the negative. It's going to change the sign on both the x squared and the 3x, and I'd keep it out front. So the first one, I'd do this. I don't change the other side because it's just sitting on the left there. Then I would take the 3 divided by 2 squared, add it inside the parentheses, and I'd go to add it to the other side, but I'd have to multiply by that -1 first. In this scenario, I think it is way easier to divide everything by -1 before you take it, so don't take it out. So that I divide every term by -1 all the way across the equal sign, and I get x squared minus 3x equals a +5. Now I don't have to worry about anything beyond the front of the parentheses. I take the 3, I divide it by 2, and then square it. I'd get 9/4. I add that inside here, and I'd add it over here. On the left side, I'd square root the x, I'd square root the 9/4, take the sign from the middle, put it in parentheses and square it. And then 5 would become 20/4 plus 9/4, which is 29/4. Then square root both sides, putting the plus and minus in front. Square root 29 over 2. Add the 3/2. And I'd get x equals 3/2 plus and minus square root 29 over 2, or combine them into one fraction. So I think if it's a negative, it's just way easier to get rid of it. Divide or multiply everything by -1, it changes all your signs. If there's a number on the front, I think they're both kind of equally complicated, but you could do either one. All right, we're going to save 8 and 9. I'm actually going to save them until, I might even save them until Thursday after your quiz, because the next couple of days are going to go like this. Tomorrow, we're going to review for your quiz. So this homework is due Friday. It's due Friday. Okay? I would recommend maybe trying at least one while it's still fresh in your mind. But tomorrow, we're going to review for the quiz. Then Thursday is your actual quiz. And we'll finish these examples. What were they? 8 and 9. And then Friday, your homework's due on the complete the square. Okay, Sebastian.
What lesson are the quiz on?
It's on 1.2 to 1.4a. So 1.2 was solving when there's a fraction and you had to check for like the extraneous roots, that stuff. 1.4a is solving using factoring and the square roots. So we have a quiz review. I'll post that today if you want to get ahead. I would focus on that for tonight. Tomorrow you'll get to work on it some more, but at least then you'll know tomorrow when you come in like what you have questions on. We'll do some more practice tomorrow in class, and then again the quiz will be Thursday. Sure. What we skipped 1.3, right? Yeah, 1. Yeah, we did 1.2. I don't even know what 1.3 is. We skip it. Yeah.
1.2A too, right?
Yeah, so A was just like the numbers in the bottom. You're not even going to see that. It's going to go to ones that have the variables in the bottom. But 1.2A had like just solving, right? With where you distributed, you solved, you'll see stuff like that. Yeah, which is on the review.
Can you zoom in?
Sure. To what, 10?
Yeah.
Sebastian.
That's only 2 lessons.
Well, it's technically 3 because from 1.2, you get, from 1.2A, you got the solving of the equations, the special cases, the no solutions, the all real numbers. All that stuff comes from 1.2. And then 1.2B, no, 1.4A was your solving with your fractions that you had to factor. No, sorry, that is 1.2B. So it's 1, 2A, 1, 2B, and 1, 4A. Yeah. Yeah.